In section 7.5, we're going to be working on some division properties that go with exponents. And again, for another little review, let's talk about the 5 properties we should already know. Done that a lot. We're going to commit them to memory. Remember, we've got anything to the 0 power is always 1. We've got that anything to a negative exponent. And again, I'm just going to use some numbers in here instead of the variables to keep it a little cleaner, but means we divide by that 3 times, or kind of equivalently, we'll put a little bracket around here. If it was, say, 1 over a to the negative third, remember the end result is that we switch levels and we go to the top to be more positive. Remember that we also had a property for multiplying with this same base. That really means we have 3 a's and 7 more a's, giving us a to the 10. And so keep in mind, sorry, someone came to the door. We also have our 2 newest properties that say that when we raise a power to another power, that means we have 7 groups with 3 in each group, giving us the product of the powers, or we multiply them. We also have that when you have a chunk of stuff, an entire product to a power, we are allowed to, and should, raise each piece of that product to the power. Alright, so we are going to apply those 5 doing these 4 problems, and if we were in class and you were taking these notes, I would have you do them, and then we go through them as sort of a little formative quiz, but for video, we are just going to go through them together. What is this simplified for? This is power to a power. Again, that's a to the 7 3 times if I forgot what to do with those and I'm debating whether I add them or multiply them. That would be 7 a's and 7 a's and 7 a's, giving me a to the 21st. I multiply those exponents. Number 2, what's the simplified form? I've got my common base of a c here, but I've also got a power to a power I'm going to work with. So I've got c to the negative third times c to the negative 8. Now I've got multiplication with the same base. I keep that base and I add the exponents. Remember, we're not allowed to leave negative exponents. It's considered bad math grammar. What I do is I divide by c 11 times. Write an expression for the area of a rectangle. Remember, area of a rectangle from geometry is base times height or length times width. If we were asked what's the perimeter, we'd add all those sides up, but this says what is the area. So I'm going to do base times height. Remember, these are called, class, I'd wait for that response, but those are called coefficients. That's 6 times 2, which always been 12. X to the 4th times x to the 4th would give me 8 repeated multiplications of x. For number 4, what is the simplified form of this one with all the z's in it? I hate z's, they look like 2's, but we'll clean it up anyway. I will monitor and adjust. So I've got z, and I've got power to a power, which means I multiply those, and negative times a negative gives me a positive 6. I've got each one of these here to go to the negative 2 power, which, and again, I can either drop the entire chunk and square it, or I can take each one individually. Again, there's often different paths to the correct answer. I can take each one individually and deal with it. And remember, power to power, I'm going to multiply those exponents like that. I don't leave those negative exponents. So really what I end up having here is I've got this z and some more z's. There's 2 ways for me to deal with that. I can, again, lots of different paths to a correct answer. I can use the property that says I add those exponents, which gives me z to the 0, which is going to be 1. Then I've got my 7 to the negative 2, which is 1 over 7 squared, sends it to the base. I already dealt with these. And then I've got my y to the negative 2, which is going to give me a y squared on the bottom. Z to the 0 is 1. 7 squared is 7 times 7. So there's one route, but I'd like to discuss the other route, because some of you might have said, hey, you said I've got to drop this down. Watch what would have happened if I had done that. So I'm just going to go over here, take another route. you might have just gone piece by piece and not noticed that you had z at the front and at the back with that same base. And you might have said z to the 6 stays on top. We use green here. So you might have taken care of that and just done level by level. This one's going to drop to the bottom to b squared. This one's going to drop to the bottom to b squared. And this one is going to drop to the bottom as z to the 6. But then you also notice you've got the same thing over the same thing. If anything divided by itself is 1. So even if you'd done it that way, these would have canceled, giving you a 1. So we get the same answer here in blue and in green with 2 different routes. Now we're ready for a new property. What do we do with division? Well, before I tell you, I want you to kind of take a look, and we're going to discover it first here. I'm going to again take what it means when I have an exponent. It means repeated multiplication. I'm going to assume I don't know or have any shortcut or property or rule, and I'm just going to write it out. This always works, by the way. The reason I do this is in case you forget from one year to the next what the rules are, or if you're debating, do I multiply the exponents, add them, subtract them, you can always write it out. And I'm going to use the fact that 3 divided by 3 is 1, 4 divided by 4 is 1, x divided by x is 1. So each one on the top cancels with 1 on the bottom. You'll notice I end up with 2 left up on top. Let's try another one with a numerical base. What does this mean? It means I've got 3 7 times. 1, 2, 3, 4, 5, 6, 7. All divided by 3 times 3. I'm going to cancel. I'm going to cancel. And you'll notice I get 3 to the 5th. And I've got a canceling effect going on here. They're not accumulating. They're canceling off, which is decreasing the number of them. And you'll notice again the link. Basically, 3 of these wipe out 3 of those, leaving 2 up on top. 2 of these 3's wipe out 2 of these, leaving 5 up on top. So the property actually says, you can guess, that we subtract the exponents. However, this is the one I actually use the least. I like to picture canceling. I just think it's kind of easy. If I have b to the 5th over b to the 3rd, 3 of these are going to wipe out 3 of those. It's going to leave 2 up on top. But because the reason I do that is it kind of saves me a step if I picture canceling. Look at what I did here. I reversed the hierarchy of those exponents and put a fewer amount on the top. And you'll notice that if I were to use the property as it stands, I will get the right answer. I'll say it's b to the 3 minus 5. I'd say it's b to the negative 2. And I can't leave negative exponents. It's 1 over b squared. However, I like to just picture canceling. What's going to happen here? 3 of these are going to wipe out 3 of those, leaving 2 on the bottom. And I kind of walk myself directly to the correct answer and avoid that negative exponent. I like that way, but you choose what works best in your brain. So when I'm dividing powers that have the same base, again, we don't do this when they don't have the same base, I subtract the exponents. Now make sure you heard every word that I said. When you're dividing powers with the same base, you subtract the exponents. Here's the danger of what I just have taught you. The same base in this problem is x. And I do subtract, I'm going to actually even put a 2 in here. I do subtract those exponents and get x to the 5th. But these are coefficients. They are not powers. And their exponent on this is a 1 and a 1. They don't have the same base. That's 8 divided by 2. That has always been 4. You might say, well, duh, LaRude, I know that. You'd be surprised that because I said when you divide with a common base, you subtract exponents. What kids hear is divide, subtract. So they will subtract these and say it's 6. So you got to be really careful that we're talking about common bases and subtracting exponents. All right. I prefer the idea of canceling. I prefer, okay, that you consider 4 of these, wiping out 4 of these. Where are they going to be left over? On the bottom. How many? 9. And I can just go like that. But if you use the property as your book and as most mathematicians would say, what do you do when you divide? You subtract the exponents. You tell me it's d to the 4 minus 13. You tell me it's d to the negative 9th, and then you do 1 over d to the 9th. I like the canceling idea, but here's what I'd also suggest you do. Before you start, because negatives tend to cause a problem, especially when you're doing subtraction, like a -3 minus a -15, that leaves a lot of room for sign errors. I would honestly suggest that when you're cleaning these fractions up, you deal with those negative exponents before you do anything else. They are kind of, again, they're negative. Get rid of them, get them out of there. We hate them. What I would suggest you do is do a quick rewrite of this. What do I mean by that? I keep all these positive exponents on their own level, like they don't do anything yet, and then the negative exponent causes that one to go up. The negative exponent sends that one down because of that reciprocal effect or division effect with the negative exponents. Now, I'd either apply this property that says subtract the exponents, or I just picture off cancellation. What's going to happen with the x's when they cancel? They'll be left on the top, and there will be 4. Or you could say 5 minus 1 is 4, add x to the 4th. With the y's, where are they going to be left? On the bottom. How many are going to cancel off? These 4 are going to knock this down 4 to 4. Or you subtract them and tell me it's y to the -4th and then send it to the basement. Either way is fine. Now, interestingly enough, you can approach the z's too. You can say, well, they all cancel. Yep, no z's in my problem. Totally right. They cancel to make a 1, 1 and it's done. Or you might say, Rude, if I subtract those exponents, I get z to the 0. True, but anything to the 0 is 1, so we put a 1 up on the top of that fraction. Next up, we've got number 1. We're going to go do some practicing. So where do I have x? These are positive, so I'm ready to go. Where do I have x's left? There are more on the bottom. There's 1 more on the bottom than there is on the top. So I end up with 1 over x. Or again, you could say it's to the 4 minus 5. It's x to the -1, which sends it down. I like this way. It's a little more intuitive. It makes sense. You don't have to memorize a property. Let's go to the next one. X's. There's 1 on the top. And I'd even put those in there until you get to be a master at this. I'm going to have 2 x's left on the bottom with canceling because this one's going to knock 1 down. And I would have 2 y's left on the top. Or if you subtract the exponents, you'll get the same thing. Again, what would I suggest you do with this one? I'd highly suggest just a quick little rewrite, even write on your paper. If you're doing a worksheet or a test, just send the 8 to the top as a positive and the c to the -3 down to the bottom. And now I deal with it just to avoid those sign errors because that tends to be the biggest problem. So let's go clean this up. I'd have 2 a's left on the top. I'd have 2 b's left on the top. And I would have 5 c's left on the top. Or I subtract the exponents for 2, for 2, for 5. Well, there's nothing left on the bottom. Technically, there's a 1, but that doesn't do anything. Now, on the top, keep in mind, watch. Even though you're 14, technically there's a 1 on the bottom, but we don't need it. But if you ate 1 out of 14 slices of pizza, that's necessary. So make sure if it's on the top, you don't leave it off. All right, moving right along. What do we got going here? Another area problem. The area of a rectangle is 72. Well, let's take all the ugliness out of it. I'm going to take this problem and tell you, I'm going to tell you the area of this rectangle right here is 80. I'm going to tell you one of the sides is 80. And if I were to ask you what's the missing side, your brain would say 80 divided by 8 is 10. Correct? So that's what we're going to do on this one. I'm given the area, so I know this entire area is 72a cubed b to the 4th, and I know one of the sides. So to get that other side, I'm going to take that area and divide it by one of the sides. All right, what do I get when I do that? Keep in mind again, these are numbers. 72 divided by 6 is 12, and it's positive 12, so it'd be 12 to the 1st. It's top heavy 12. So it's going to be a 12 up on top. So you're out. Next, my A's. I have more A's on the top than on the bottom. I'd have 2 A's up on the top. So technically both of these are out. But let's finish it up. I've got 4 B's on the top and 1 on the bottom, which leaves 12A squared B one more power, property, and then actually we're done with all of them in the chapter. So that would give us what? 6 of them plus a scientific notation model. So 7 things you gotta have rock solid. 7 really important skills in this chapter. All right, so we must be proficient with our last one. What do we do when we've got all of a division to a power? Well, when it was a multiplication, we were able to bring it in. Same thing with division. So we're allowed to just take everything in the parentheses. As long as there's no addition and subtraction going on within the parentheses here, we take that power and we distribute it into everything. This is going to be 2 to the third. This is going to be p to the third. This is going to be 3 to the third. And then a lot of times, when these are small and you can tackle them without a calculator, you should. 2 to the third is 8. And on the bottom, 3 to the third is 27. That one's done. Notice on this next one, I've got that negative out front there. It's not in the parentheses. That's really -1 times that chunk of stuff. And so my answer is going to be negative. There, I've just dealt with that. Now, if it was in the parentheses, it'd need to get squared. And the negative times a negative is a positive. So the location of that negative is incredibly important. So now what do? I square everything in those parentheses. I'm going to have 2 squared. Boom. X to the 6 squared. Now again, don't guess. Is it 6 squared is 36? Do I multiply them for 12 or do I add them for an 8? If you don't know for sure, not 100% sure, think of what it means. When I square x to the 6th, I do it twice. There's some sort of machine outside my window. That's going to give me 12 of them. I multiply those exponents when I have power to a power. On the bottom, I've got y to the 4th squared, power to a power. I multiply them. 2 y to the 4ths. 2y to the 4th and another one. I'm going to have 8 y's in that expansion. And then I've got x to the 2nd. And in class, I'd stop and say, okay, why would I still take a point off on here? When we say simplify, that means you get it down to its skeletal answer. I still have a common base here of x, and I need to deal with that. And it's division. I could have dealt with it within the parentheses. I'm dealing with it at the end. Again, it's all about different pathways. Just don't break any rules. So what do I have going here? The negative, done. The 2 squared, which is 4. X's. I have 2 on the bottom that are going to cancel out 2 on the top, leaving 10 on the top, or I subtract the exponents. And on the bottom, I've got 8 y's. All right, so the next one up. This is kind of a longer lesson, sorry about that, but that's the way it goes. Describe 2 different ways to simplify this expression. And I would like you to pause this video and just do one way that just immediately pops into your head. And I'll tell you what usually in class what happens with that. So pause this video, you go clean this up, and then see which route you took. Most common method, method number 1, is bringing this power in. Totally legal. Saying it's a to the 21st. Over a to the 15th, recognizing the common base, and then saying there's 6 more on the top than on the bottom, or subtracting those. Correct answer, 100% super. But we've also got another method here that we could do, and think outside the box, just because the most recent property we did said bring that power in, it's legal. You could also go in the parentheses and say, hey, I got a common base in there, and I've got 2 more on the top than on the bottom, or I subtract those exponents and get a squared, and I'm to cube that. And now I've got power to a power, in which case I multiply exponents. Notice I've got a little different attack here. This looks entirely different than this, but I used my 7 rules properly, and I did not break them. So I got that same end destination going there. All right, so next up. It says you can write an expression of the form a over b to the negative n using positive exponents. And here's my answer box right over here. And again, kids always like shortcuts, so listen up, but I'm not going to give it to you without showing you why it works. So we're going to take this one on the long route. Suppose I haven't taught you a shortcut yet. Here we go a long way. I bring that negative n in. I say it's a to the negative n over b to the negative n. I don't get to leave negative exponents. So I say, well, b's up on the top to the positive, a's down to the bottom to the positive. Then I could actually say, well, you know what, that's actually the whole thing to the nth power. Now notice what's happened here. analyze my solution, or my simplified form, with the original. And you'll notice what's happened. This inside fraction has flipped and become b over a. The exponent has become positive. So basically, in words, when we raise a fraction to a negative exponent, we flip it and go positive. Again, it's that whole reciprocal or level changing effect of the negative exponents that allows us to do that. You might say, well, how is that a helpful property? It's actually, you could never use it and you could still get the right answer, but it sure makes things cleaner. And let me demonstrate that with this next problem here. Again, instead of distributing that into everything in the fraction and taking one negative and distributing it into everything, we don't like negatives. I mean, they're our least favorite to work with. So what I'm going to do is use this property and flip this fraction over, make it y to the fourth over 2x to the sixth, and raise it to the positive power. Now notice what I've got. I've got a much cleaner problem to work with here. I don't have all those negative exponents going on, so I can just click this one off pretty quickly. Power to a power, I multiply. Now I'm bringing a positive 3 in instead of a negative third power, so that it just makes it cleaner. 2 to the third is 8, and 8 to the sixth to the third, x to the sixth to the third would be x to the 18th, because again, power to a power, we multiply those exponents. Notice how smooth that was, getting rid of the negative exponent first. So I would again like you to pause this video and go do this one, and then start it again to check it. So what I've got going here is, again, I would take the fact that I've got a fraction to a negative exponent, and I do that right now. I'd flip that sucker over, and I raise it to the positive 2. Now I would square everything in here. 5 times 5 is 25. B times B is B squared. And on the bottom, another A squared. No cleaning up possible because I don't have any common bases. And last up, let's tie in what we know about our scientific notation with our new properties. This one's actually really good. I'll tell you when I'm done with it. So it says during 1 year, we've got Honduras that has this many people. That's a lot of people, 7 million and some. And its area is this much. What is the population density? This, you might not know what this is saying. When we talk about population density, it's how many people per square mile. Tells you kind of how packed in they are. Like if we were talking about this room is maybe, 20 by, well, probably more than that, but let's suppose it's 20 by 20 and it's 400 square feet. The population density in here would be 35 people per square foot. So to get that, you take your total number of people and you divide it by the total area. So what we do is we say population density is 3.3 times 10 to the 6th, means spread out or divided up amongst an area that is 4.33 times 10 to the 4th. Alright, so that's going to give us people per square mile, because this is my peeps on the top and these are my square miles on the bottom. So how many people on average, if I were to spread them out, would be sitting down on every square mile of land? So how do I work with this? What I do is I take those coefficients and I divide them, and I would do that on my calculator, so I'm going to grab that right now. I obviously wouldn't expect you to divide those by hand. I'd have 7.33 divided by 4.33, and I get a 1.69, let's go to 3 decimal places, it goes on quite a bit. And then I've got 6 tens being multiplied on the top and 4 on the bottom, which means I'm going to have 2 left over up on the top. What does this mean? If I leave it in scientific notation, it means I have 1.693 times 10 to the second people per square mile. However, this isn't really how you would leave this. You would actually put this one out of scientific notation because, 10 to the second is just 100. So I'm really just going to multiply by 10, I have about 169, because you never say you have 0.3 of a person, people on every square mile of land in Honduras. Now keep in mind, that's if I were to spread the population out evenly. we tend to clump into the city areas, so, but that's just what we call population density. I'm done, that was a long one, yowza.